Welcome to BA for Space. I bring you business, data, and financial analysis concerning our favorite subject, commercial space. And this week is a special pitch deck edition where I'll be proposing a new startup concept related to the commercial space industry. And this pitch will include a summary of the idea, general information about the industry, a marketing plan, competitor analysis, and profit and loss projections. So what's the concept? This week we will be pitching a startup that will develop a mobile and autonomous refinery of lunar regolith into oxygen, hydrogen, and additive manufacturing for lunar and cislunar fabrication and architecture. The device will be capable of operating autonomously and will interface with orbital operations, landers, ascent vehicles, and low Earth orbit construction initiatives for potential vendors, partners, and customers dedicated to space in situ fabrication and refueling activities. So what problem does our device provide a solution for? Currently, all space activities from suborbital, orbital, cislunar, and outer space missions rely on fuel that originate from Earth, representing 90% of launch vehicle mass. Staging launchers deals with the propellant mass, but that's just to get out of the Earth's atmosphere, perform orbital stabilization maneuvers, and propel the vehicle to other places in the solar system we want to go. By adding the ability for fuel to be generated on the lunar surface, we eliminate the requirement of taking more fuel than is necessary to achieve low Earth orbit. We can rendezvous with refueling crafts originating from lunar surface at a lower lunar ascent requirement, as the gravity to overcome is 1/6 that of the Earth's. And furthermore, due to the properties of lunar regolith, other volatiles such as hydrogen, oxygen, and other compounds can be generated to facilitate lunar surface life support activities, manufacturing energy sources, and water for human and plant sustainability. So what's the solution? By providing fuel and volatiles produced on the lunar surface, we can ensure long-term company viability by filling the needs of launch providers, mission planners, in situ space architects, extraterrestrial mining companies, and government entities. We decrease complexity to their mission architecture and provide a steady stream of revenue and growth to our own company mission and financial goals. So what are the risks? Current risks include autonomy of the proposed solution, the interface standards required of our customer, vendors, and partners, the forecasts of extraterrestrial business activities in a new and growing commercial space environment. So what are we asking for? The ask comes down to a phased contingent series of funding provided benchmarks are met throughout the timeline of the company development and growth. Series funding will depend on investor buy-in on the viability of each phase. The first phase will be research and development of the fuel generator device itself, and we will run parallel market analysis to determine customers, vendors, and partners that show an interest in using our services. The device will be controlled by terrestrial mission control team, but because of the time lag between the Earth and the Moon, operations cannot be practically controlled in real time. Therefore, autonomy is a practical requirement of the device. We ask for $2 million to develop a proof of concept of the device itself and $1 million to fund a market analysis report that will include channels, industry competitors, market share potential, and revenue growth projections. Once the seed funding phase is complete, we'll require an additional series of funding for the testing phase. The device will need to be tested on Earth through simulation before branching out to the lunar surface testing rounds. The majority of funding in testing phases will be that of operational testing and iterative device modifications. The second series of testing will include lunar operations, but launch costs of the device will be one time. These are non-recurring, as the remaining tests of the unit will be conducted on the Moon. To that end, we ask for $2 million per year during the testing phase and one-time amount of $10 million to secure a launch as a secondary payload. Once the build phase of funding is complete, we ask for Series C funding to optimize operations and build a customer base through marketing, sales, and partnership initiatives. To that end, we ask for $5 million a year with a proviso that established benchmarks of success are met. So, concerning the industry analysis, in situ resource utilization is a subject references in so many space-related activities as a solution to include NASA missions to Europa, SpaceX proposed missions to Mars, lunar resource extraction from space resource companies such as Golden Spike, and support services such as Lunar Express and Voyager that hope to expand space operations and commercialization. But viabilities of all these activities depend on living off the land. Industry confidence is growing, as demonstrated by the amount of money venture capitalists are putting into private space ventures. And according to Fortune, private equity firms have invested $8.2 billion into private space in just the last 5 years. New launchers are coming online with their own suite of specialized services, and the frequency of launches are now weekly. Microsatellites are proving viable and ubiquitous, and larger satellites face premature retirement due to positioning requirements and no current way to refuel them. Concerning the fuel and materials limitation that exist on the launch pad, an in-situ solution complements an old aerospace saying that once you're in low Earth orbit, you're halfway to anywhere in the solar system. So what are the threats of new entry? Current threats of new entry include standardization of interfaces across customer and vendor spacecrafts. We will need to communicate docking and fuel transfer standards and requirements to potential customers and vendors. While current capital costs are high, a good percentage of them are one-time. We will need to adhere to governmental standards, as a good deal of initial service delivery will be entities requiring refueling at a lunar orbital range. However, once proof of concept is established with these larger government entities, smaller and supporting companies will engage as part of complementing suite of services. So, what's the power of suppliers? Currently, there are no in-situ resource suppliers to compete against in this emerging market. Market dominance of our company will be dependent on not only servicing refueling operations, but materials fabrications as well. Product and service differentiation will help establish our company as primary innovator, good branding, and the standard that following competitors will strive to achieve. So what's the power of customers? The customer base will be limited to large entities at first, but expand to suppliers of other space-related activities such as space architecture and mining-related companies that will follow. The first stop in any space-related mission will be refuel. Whether that refuel is done on the surface of the moon or in low Earth orbit, or even in strategic Lagrange points for deep space observation-related companies. So what's the threat of substitutes? Given that initial market penetration poses no threat of competition or substitutes, it will be important to establish entry and exit criteria for each phase of the product deployment. Once the proof of concept is made public, substitutes will be numerous, will service, speed, agility, and innovation being the only differentiators between competitors. Long-term competitive strategy must include expansion of services, streamlining of operations, in-situ fabrication of backup units in the event of total system failure, and periodic service offering recommendations for future operational integration. So what's the marketing strategy? The marketing strategy for the proposed solution is predicated on one simple truth. We service secondary markets, not the end consumer. We are business to business, therefore we do not need to waste resources and time on popular appeal. Simply be the company that is providing a solution to primary launch and mission companies. While to target demographic is business to business, there is a high priority for strong branding. We need to focus on channels of information distribution to include industry conferences, white papers, demonstration and exhibition videos, industry investigation, and ongoing probes of potential customers. A good deal of effort will focus marketing activities to grow customer base, negotiations of launch providers, and letters of intent from secondary service providers. The key to the marketing strategy will be why customers need to modify their existing hardware to accommodate our refueling technique. This will require solid promotion of flexible services, reliability, and sustainability to be able to adjust to long-term mission durations and requirements of the customer. So what are the channels? Basic channels of marketing will include a strong but simple optimized website, partner-specific portals to ensure our customers have all of the latest information that we provide, but ensure that proprietary data, metrics, and sensitive information is not freely available. Our channels also need to provide our customers with partnership solutions for any roadblocks they will have. We will have to communicate to our customers that their problems and roadblocks are our problems and roadblocks. If we provide solutions on a passive level, we can ensure that their mission is fulfilled, in turn, ensuring that our mission is fulfilled. Other possible channels include consultant firms, value-added resellers, project management teams, and space-related brokers. Marketing to these verticals ensure brand recognition and service retention. Social media marketing efforts should be restricted to these channels. Public awareness should be passive and secondary to primary channel marketing strategies. So, profit and loss projections. Revenue projections for this service depend on the cost to our customers being drastically reduced from the equivalent terrestrial launch and refueling costs. The cost restraints associated with orbit and lunar activities are related to mission design. If an extraterrestrial mining operation wants to get the near-Earth asteroid, they must factor in launch, fuel, and duration costs from the ground to the asteroid. If they can refuel in orbit, the cost of launches are significantly reduced by virtue of not only dry mass, but mission constraints related to consumables during the life of the mission. We propose a price-setting scheme of all upfront research and development costs distributed over 5 years as the initial cost of fuel resupply. For example, if funding phases distributed out equate to $2 million in seed, $2 million per year, which equals $10 million total, $10 million one-time launch divided by 5 equals $2 million per year total, which equals $14 million distributed over 5 years, which is $2.8 million per year of costs. So cost plus 30% margin equals $3.6 million in refueling costs. An additional incentive to the price points could include refueling services over the span of a year to equal $3.6 million per customer. So the anticipated revenue, given the projected cost of our service, we anticipate filling a market capacity of space-related refuel activities at least 10 times within the year, totaling $30.6 million in revenue, annual revenue. So what are the operational costs? Ongoing annual costs include lab, rent, and fee materials for proof of concept of analog testing device to troubleshoot in situ problems. They include employee salaries, insurance, upfront launch costs, sales, marketing, and research. To the tune $2.8 million is anticipated as a total of operational costs. For a gross profit of $2,600,000 after costs of services, insurance, equipment, and utilities, we anticipate net annual earnings of $2,376,000 after the third year before growth and expansion phase is initiated. So are we looking for all now or just some later? Anticipating a choice from the investment firm of all of funding provided up front or distributed throughout the funding phases, we suggest a 50-50 split between seed and growth stages. So approximately 90% of funding requirements will go into the proof of concept of the device itself, the demonstration of the device viability, and the analog device for troubleshooting purposes. So follow-on business will decrease upfront cost requirements as there will be no follow-on launch requirements of further devices within a 5-year span. After devices landed on the lunar surface and we verify operations and diagnostics of focus of operations and marketing will be on repeat business, communication of services to potential customers, and follow-on services of mission planning with partners, vendors, and customers. So what's our exit strategy? Once the revenue benchmarks are realized, we suggest a phased exit strategy. The first benchmarks of sustainability will need to be achieved to demonstrate that operation revenue and costs have been realized. There is repeat business in the industry, and profits have been appropriately allocated to investors, and future reserves for additional devices and operations. there will be an option to either divest at a given percentage or reinvest with full disclosure of company mission and vision directives. So what are our conclusions and recommendations? In situ resource utilization is a catalyst of a multi-trillion-dollar industry given projections of Morgan Stanley in 2018. They anticipate a $1.1 trillion industry from $350 billion as of right now. Even in the current market environments, there is more than enough revenue potential to fulfill the revenue projections listed earlier. There is also ample opportunity for follow-on services, relationships with other verticals, and intellectual capital to not only sustain the future of our startup, but grow it exponentially well into the future. I thank you for your time and consideration. And all cited references are below in the description, and an example of profit and loss statement is also provided. Thanks for joining me on this week's BA for Space Pitch Deck edition, and I will see you all next time.